All right, welcome to this lecture. We're going to continue on the topic of lambdas, and we're going to slowly start to get practical, okay? There's just a couple of things that I want to introduce to you, and I need to do them slowly so that you don't miss a heartbeat in this process of learning lambdas, okay? So bear with me as we go through this, and you're going to get plenty of practice in the process, okay? So let's first create a new package in the Lambda practice project. The previous classes that we created were in the default package. I didn't name it, but I'm going to create a new package here in the source, and we're going to call this lambda.practical, because we're going to start to get into the practical components of using lambdas, okay? So I'm going to create a new class here, and this is going to be an example of cars. And I'm going to show you how you can work with lists, or collections of data. So we're going to have a bunch of cars, and for that we need the actual car class, so we can create instances of cars. So let's do that. We're going to hit finish. This is our car class, and it's going to have a few member variables. It's going to be a very simple class, the make, model, and the color. And let's also give it the price. So these are the member variables. Now I can generate constructors for this. So go to source. When you right click here, go to source. You already know this. Generate constructor using fields, and it's going to select all of them, hit generate. And now we're going to generate the getters and setters. So right click, source, generate getters and setters. Where is that? Right here. And select all. And then finally, we also need a toString method so that we can print this object in a user reader-friendly way. So right click here, source, generate toString, and we're going to leave those fields, and I'm going to implement one more method which will be used to print the object. So we can do, we'll call this print car, and this is also of course a public method. It doesn't return anything, and it doesn't accept any arguments, and this is just going to system.out print this. Okay, and what is this? That will be the particular instance that is created of this class, and we'll be able to print it, and it's going to print it in this user-friendly or reader-friendly manner. And that's it. We've created our car class. It's just that simple. The next thing is the app class, where we're going to test some of the functionality with lambdas, and I'm just going to call it app. We'll have the public static void main method in here, and in here I'm going to create a list of cars. And your code, your source code that you download for this course should already have this. So I'm going to paste that list right here. Okay. So notice that we are creating a list called cars, all right, and it accepts cars. So these are the different instances of cars that we created, and we're using the arrays.asList method to populate this list with all of these instances of cars. If you do a Command-Shift-O, that will bring in the java.util list, okay? And now this should be compiling. I'm going to create two methods that can interact with this list. And these are, traditional methods that you've been developing in the course so far. One of the methods is going to print the vehicles based on a given price range. And the other method is going to print the vehicle based on color. So if you want to get all the red cars, it'll print all the red cars. If you want to see all the white cars, it will print all the white cards. And in the interest of time, I'm going to save you the typing here to keep this video a reasonable length. So we're going to fast forward to where these methods are created. And you should have these methods, by the way, in the source code that you download. And here are those two methods. First one is called print cars price range. So it takes a low and a high value, and it prints the cars that fall within that given price range. And it has just one if statement, and it's calling the print car method. And similarly, the other method, print car by color, does exactly what it sounds like. Okay, it has one if condition where it checks to see if the color matches the argument that's passed in, and it invokes the print car method on that car object. So simple methods. Now look closely at both of these methods. What is common across both of them? They obviously take the cars list as an argument. That's one commonality. And the other commonality is that they both involve conditions. Okay, there's an if check in the first method as well as an if check on the bottom, the second method. So they both involve conditions. So if the condition evaluates a true, the car is printed. That is the common theme across both of these. Now to use these methods, all I'd have to do is invoke them in the main method, and pass in the given range for print car's price range. And for the print car by color, I just have to pass in the color that I'm interested in printing. So we have this list of cars, and we provided our clients with the ability to interact with this list by using our methods, such as print cars based on price range, print car by color. But what if they wanted other things? Let's say they wanted to also print cars based on a particular model or a particular make, or including all of these attributes such as make, model, color, and a specific price. So for that, you'd need to create a bunch of other methods, right? They would have different method signatures, and the commonality between all of these would be that there's just a condition within them that's trying to see if the condition is met, and only then it returns a car. Now think about how we can improve this code. Rather than having so many methods with different method signatures, is there a way that we could provide just one method to the user and they could just invoke it and pass in their own conditions, however they choose, their own conditional clauses? Well, we could do that using lambdas. And that's going to drastically reduce the lines of code that we need in our program, right? We won't need a bunch of these methods with different method signatures. We could just have one method and allow the user to be able to use lambdas and to create their own conditions. So let's go over how to do that. So instead of having these multiple methods here, I can just define one method. And let's just say that that's going to be a static method that is supposed to print cars. Okay? And we don't know what the conditions are for the cars that we want to print. We'll leave it up to the user of this method. So the list of cars is the first argument. And the second argument, I'm going to call it car condition. Okay, and we'll leave this condition up to the user that is trying to print the contents of this list. We'll leave it all up to the user of this, the client of this code. For car and cars, we're going to just do a basic for loop. And we're going to see if the condition dot test, if that is true, only then c dot print car. Okay, so we're creating a level of abstraction here. This will only, the car will only be printed if the condition evaluates to true. All right, what is the condition? I haven't created this yet. Okay, and we can use lambdas to do this. So first things first, we need to create a functional interface. Okay, so if you highlight here, notice it says create interface car condition. So let's accept that suggestion, click on that, and it's going to, we could just say finish. And it created that car condition. As a matter of fact, instead of creating a new file, I'll just keep things simple. Let me close this. I'm going to put that in the same file as app, okay, just to keep things in the same place, in the same file. And I'm going to get rid of this car condition.java. Let's delete that. And since it's in the same file, this shouldn't be public. We'll just leave it as interface. So now car condition means something. And this test method doesn't exist as an abstract method in car condition. So let's define that. That's going to be a public Boolean, right? Because it's either true or false. It's conditional, and we're going to call it test. So this is a functional interface. Let me follow best practices and say that this is a functional interface by putting in the annotation right above it. We need an argument for this method since we're dealing with cars. So this is going to accept a car. And now the code should be compiling. As you can see, there are no errors. So instead of having both of these methods that we've defined, one for trying to figure out the range, one for trying to figure out the color, we can just leave that behavior up to the client. We're giving them that flexibility in however they want to implement the test method. We're leaving this up to the client of our code. They can implement test however they please. So now we no longer need these two methods. Before I get rid of them, let's actually show you how we could convert this behavior into a lambda expression. So we're no longer invoking print cars by price range and print car by color. We're going to comment these out. We're not going to utilize those methods. We're now going to only utilize one method, which is print car. So let's do that. Print cars. The first argument is the actual list, which is cars. And the second argument is the actual condition. Okay, so here we have two options. One, we can define a lambda expression, or we can use an anonymous class definition, right? And you know how to do that. Let me just do that. Let's just do a new condition, or excuse me, car condition. And in the body of this, we're going to implement that test method. Notice it's complaining. It's saying, hey, we need to implement the inherited abstract method test. So let's accept that suggestion. Click on that and notice it fills out that test method here. So what is this test method going to do? It's going to return whatever we want it to return, either a true or a false, based on the criteria that we give it. So in this case, let's go for the example of printing cars within a price range. We could literally just do this, copy this condition, and do return c.getPrice is greater than or equal to whatever range we want. So let's just choose the same range that we used in this example. So 18,000 and c.getPrice is less than or equal to 22,000. And there we go. We've implemented our test method for this invocation of print cars. And we can implement this test method however we like, okay? We're leaving this up to the client that wants to utilize this interface. So let me copy this and paste the same code here. And instead of doing this range, we're going to try to do the behavior for color. So we could do c.getColor. If that is equal to the color, whatever color we want, let's just choose blue in this case. And that's it. So if the color of the particular car matches this blue, then that will be the car that is returned. So what is common between both of these implementations? It's utilizing the test method. This returns a Boolean, okay? It's a condition. So I'm just gonna do a sysout print line statement and say that we're printing cars between price 1800 or 18,000 and $22,000. And I'm gonna do a similar thing for the second implementation of conditions, which is we're printing all cars that are blue, printing cars that are blue. So let's right click and run as Java application, and you'll see that here is the car that falls within this range. And then here are the two blue cars. So again, instead of implementing these two separate methods, right, we are leaving it up to the client. We are sort of disassociating the behavior from the program, and we're leaving it up to the client to implement the condition however they choose, right? We're not hard coding functionality here. We're making it much more dynamic and flexible for the user of this class to implement the condition however they choose, all right? And that eliminates the need for these kinds of methods. We don't need these methods anymore. All we need is, we do need print cars because we are printing cars based on whatever condition the user implements. But the other two, we don't need these guys. So let's get rid of them. Okay. So notice using just one method, we are dealing with two different implementations. This is also polymorphism. You should be aware of this already. Print cars is being used in two different ways. And it could be used in an unlimited number of ways. You can implement the test method however you choose. Okay, I'm repeating myself multiple times, but I don't mean to bore you, but this is important. I want this information to be downloaded into your brain as you watch this video and practice with me, okay? So now let's convert this into a Lambda expression because you know that we can implement a functional interface as a Lambda expression. Instead of implementing it as an anonymous class like we were in Java 7 and before, in Java 8 we can use Lambda expression. So let's do that. The first set of behavior is this, right? So I'm just going to copy this ditto, all right, and invoke the print cars method, print cars. And the first argument is, of course, the list of cars. And the second argument is the condition, right, the car condition. And we are implementing that like this, okay? So what does this need? We first need a open and close bracket for the Lambda expression, and then we need an arrow, and we are almost done. It's going to complain. It's saying that Lambda expression signature does not match the signature of the functional interface. What is the signature of the functional interface? That's test, right? We've defined it down here. Test. What does this accept? It accepts a car. So we're missing a car argument here. So let's just put C, and now it will work fine. Again, since this is on the same line, we don't need the return clause here. We don't need that. If it was on multiple lines, we would need the return clause, and we would of course need the curly braces. So that's one implementation of print cars using a lambda expression. Let's do the other one, which is going to be pretty much identical, and that is just this thing. Everything else is the same, we're just changing the condition to blue. Okay, so we changed these anonymous class implementations to something so simple. Just 2 lines to do the same thing. And we have lambdas to thank for that. Now, this is a list of cars, okay? But we could have a list of anything, right? This is a specific object, car. We could have countries, files, all types of entities in our program. So let's not hard code our interface to just use cars. Let's make it a bit more flexible. How could we do that? We can go all the way down. Let's look at the interface, the functional interface, and let's change this to a generic interface that accepts a type. We'll call it T. And now we'll say T is the type that it accepts, and it returns a Boolean. Okay, and now nothing changes here really. It'll still work the same. We just have to make sure that in the definition of this method, we have to specify that this is going to accept the type that we expect. So since we're dealing with cars, we're going to say that this takes in a car. And now both of the lambda expressions are compiling. These anonymous class definitions, let's get rid of them. We don't even need this. So we'll have the print line statement right above this first lambda expression, and we'll have another print line statement to say that printing blue cars. And we'll leave this up to the user. They could change this to blue, red, whatever, or change this conditional expression to whatever they please. It could be a multi-liner, it could be on the same line, doesn't matter. We leave that all up to however they intend on implementing the car condition interface. And now since we made the car condition interface into a generic, this can accept a list of any kind of object. So let's just change this. Instead of car condition, that doesn't work well for this example since we're making it generic. Let's just change this to condition, okay? Since we're not limiting ourselves to just cars only. Now with the introduction of lambdas in Java, the designers of the language provided us with functional interfaces that we can use out of the box so that we don't have to create our own interfaces like this, right? All this interface contains is a single method, right? Which is called test, right? It's just and we leave it completely up to the user of the class, user of the interface, however they want to implement test. So isn't there an interface that already exists that the Java designers provided for us that does something similar to this? Believe it or not, there is, and there are many. Okay, in this case, we are just having a Boolean return value from this lambda expression. So we need an interface that has a method that returns Boolean and that is generic enough to work with different types of objects. And that interface is called predicate. Let me just type that up here. So instead of having this car condition, I'm gonna change this to predicate. And that accepts a car, and we'll call this predicate. So let's hover our mouse here, and it's saying that do we want to import? Yes, we do. And where do we want to import it from? It's from the java.util.function package. So click on this first import option, and you're going to notice on the top, it brought in the java.util.function.predicate for us. So this package actually has many different interfaces, functional interfaces that we can use within our code so that we don't have to define our own interfaces when we work with lambdas, okay? Very useful to go through that library, but we need to change some of this. Since this is now a predicate, that's what the variable is called. Let's change that to predicate. And the test method already exists on the predicate. If we go to the definition, control click this and notice that this is a functional interface. It's a generic functional interface because it accepts T, and this is the method in here, okay? And this is basically pretty much the same as the method that we had in our functional interface, okay? So let's get rid of that. We don't need that anymore. We're utilizing the one that Java provided for us called predicate. And the code will run exactly the same way. So let's right click, run as Java application, and you'll notice everything is working as expected. So similar to predicate, there are other interfaces, functional interfaces that we can use. Let me show you some of them. So here I've pulled up the Java docs from the Oracle website. Notice the URL, it's docs.oracle.com/java-se/8, Java version 8. And you'll see that these are the functional interfaces. It's in java.util.function package, all right? And so it says functional interfaces provide target types for Lambda expressions and method references. So the one that we used was predicate. Let's find that here, predicate. So there's multiple predicates, as you can see. I'm just going through the list, and here it is. This is the one we used. So if you scroll down and look at all these, there's plenty of options that we can use. Now here's another functional interface that is very useful to know, and it's just called function. That's the name of the interface. And notice it says represents a function that accepts one argument and produces a result. So let's take a look at how this works. So when you open that up, notice T is the type of the input to the function, and R is a type for the result of the function. Let's scroll down to see the method signature for the abstract method, and that is called apply. It takes an input argument of type T, whatever type T means in your application. We'll go over the example, and it returns of type R, okay? So you can code the apply method however you choose in your Lambda expression, as long as it conforms to this contract. So let's actually define a variable of that interface, that functional interface type, and that is function. And let's actually first take a look at the code for this class. Let me just Command-Shift-O, and notice we can bring in the import from java.util.function. Let's bring that, and we can control-click this and see what this has to offer. So this is a functional interface, okay? It accepts an input argument and a return type. So notice this method has a return type of R, and the input type is T. So we want to make sure we get the order of those arguments correct when we utilize this apply function in our code, and I'll show you how to do that. Now another thing I'd like to add is that if we scroll down, you'll see that there are these default method implementations. Now before Java version 8, this was not possible, but in Java version 8, the designers of the language decided to include this feature where we can have these default method implementations in an interface. Now, interfaces have been around for a long time, right? From the early versions of Java 1.2 and 1.1, interfaces hadn't changed up to all the way to Java version 8. Many years later, they decided to include this new feature of having these default implementations. So why did they do this? Well, they needed to do this to support some of the new functional programming abilities that they introduced in Java version 8. There's the Stream API that they implemented, and if we didn't have this ability to have default method implementations, we couldn't implement the Stream API. All right, so that Stream API is actually very useful, and you'll see that in the next lecture when we go over that. But to support that sort of behavior, working with lists and so on, they had to also allow for default method implementations, and this does not break backward compatibility. Okay, but anyway, we're dealing with this apply method, which is the abstract method here. So let's work on that. So the way I envision using this functional interface is I want to basically be able to convert a car object to a string representation. Okay. So the first argument is a car, and the return value is going to be a string. And of course, like I said, these arguments could be of any type. Remember, this is a generic functional interface. So I want to convert a car into a string representation. Let's just say that we want to see only the price and the color. So I'm going to name this variable price and color. Okay. And so now let's actually assign it a Lambda expression. And that is going to be, we need those brackets here, and then we also need the arrow inside of here. We'll have our Lambda expression. So since we're dealing with a car object, I'm going to make this C. All right, and this is going to be of type car. So now we could do C dot get, let's get the price first. And then I'm going to concatenate it with C dot get color. In the middle, I'm going to have a string Over here, it's going to say color is equal to the given color. And let me actually put a string in the beginning as well, so that it's much more explicit what we're trying to do. Price. So we get the price as well as the color. That's the only thing we want this method to, or this price and color variable code block to contain, okay? And this is going to return this expression, all right? Now, if this is short enough to just put on one line. So let's get rid of this return and put it on the same line. And we also don't need these curly braces, do we? So let's get rid of that. And then finally, one more shortcut. I don't know if I showed you this, but if everything's on the same line, we can actually get rid of these parentheses as well. Okay, I like to leave them there because it just makes it easier, especially if you're a Java developer. You're used to seeing arguments and parameters within these parentheses. So I typically leave my Lambda expressions within these parentheses, but that's just another shortcut or another way of making your code more succinct. But I don't like to make things over succinct. I think this is just perfectly fine. Let's leave those parentheses there. But notice what this block of code is doing. This Lambda expression is taking the price as well as the color from the car object, and it's basically concatenating those data values and returning it as a string, okay? So that's why this is the return type string, and the input argument is the car. If we want to utilize this, we could do price and color dot apply, right? This is that functional interface method, that abstract method, and pass in a car object. And so we already have a bunch of objects in this list, so we could just say cars dot get the car at the 0th index position, which is going to be the first car. All right, and so this is going to return, what is this going to return? This is going to return a car of type string. Okay, I'll name this something else, string car. And then we can print that string car like that. Let's make sure we have the casing correct. And let me comment out all this other stuff. We don't need this now. We're done with those examples. So let's right click and run as Java application. And boom, there you go. So this is another functional interface that Java provides for us. Have an input data type and have a output data type right here. So in this lesson, I showed you how to use these some of these functional interfaces that Java provides for us. Okay, so you don't have to create your own functional interface for every Lambda expression. Okay, there's a whole library of these functions that Java provides for us that we can use, and they're in the java.util.function package. So we've covered all of the background needed for the Lambda expressions and how you can use these functional interfaces to do your own functional programming in Java. In the next lecture, I'm going to show you how you can use the Streams API to make working with collections and bulk processing much easier and more expressive in the code. Okay, and that's of course going to utilize everything that you learned up to this point in Lambda expressions. So thanks for watching. Let me wrap it up here. I'll see you in the next lecture.